Hello, welcome to another video on how to solve system of equation in GAMS. So today we want to use a different method for solving the system of equation. So the matrix inversion method. Okay, so to solve the system of equation, this AX equals B, we can find the inverse. We can rewrite this as X equals A inverse multiplied by B. So to do that, to be able to solve for X, we find the inverse of the coefficient matrix A, and then multiply by the right-hand side B. So the inverse of a matrix can be determined using the identity A multiplied by A inverse equals I. So where I is the identity matrix. So the identity matrix is the matrix that has 1 as the diagonal element and 0 everywhere else. Okay. And A inverse is the inverse of the matrix that we obtain from the coefficients. Okay, so how do we do this? We define the required set, define the matrix A and the identity matrix, and then define a variable inverse A and a dummy variable, I call it dummy var underscore var, and then define and declare the equation to be solved. So this is basically the equation. So the inverse of the matrix multiplied by the matrix is equal to this identity element. So, okay, and then the dummy variable is equal to 0. That's the second equation. So remember, we are using the idea of optimizing that dummy variable. So we just introduce the dummy variable and set it to 0 and make it equal to 0. Okay, then solve the model using LP, minimizing the dummy variable. So when you do that, you're able to calculate the inverse matrix. Okay. Then after calculating the inverse matrix, to calculate the values of X, remember that is our goal, we then do the matrix multiplication again. So we repeat the steps, and then we multiply the inverse matrix by the right-hand side B. So these numbers here. So we multiply them, and then it's to obtain the values of X. Okay. Then we repeat the above steps for the matrix multiplication to be able to do that. But this time around, we need just 2 sets instead of 3 sets here. Okay, let's see how we can do this in GAMS. Here is the code. So I have set I declared as A1 to A3, and then alias to replicate that set into 3 because I need 3 sets for the matrix multiplication. And then define the set E using table, and then define parameter identity matrix. So then assign the value 1 to the diagonal element. So when you have the point A1, comma A1, then we assign 1. So 1 will be A1, A1, then 1 will be A2, A2, and 1 at A3, A3. Okay, so when you have the same element, yeah, it's going to be 1. So it's going to be 0 everywhere else, because if we don't assign anything in there, GAMS will automatically assign values of 0. Then define the variable, the inverse matrix, and the dummy variable that we need for the optimization. Then define and declare and define the equation. So the equation I want to write is this, and then the dummy equation. So basically, the dummy variable equals 0. Then write the equation, so which is basically the sum over K, the controlling set of the inverse matrix multiplied by the matrix is equal to the identity matrix. And then this dummy equation is basically dummy variable equals to 0. Then solve the problem, call it system of equation, or include all the equation, then minimize by minimizing the dummy variable. So you use LP to solve it. Then after doing that, we're able to calculate this inverse matrix. Then the next thing to do is to, capture the value of this variable by assigning it to a new parameter. So basically, I created a new parameter, and I assign the values of the inverse matrix I calculated here to it, and then declare the parameter b, which is the right-hand side, and then the variable x that I want to calculate, which is basically the solution that I want to calculate. Then I declare a new dummy variable, dummy var2, and then equation I want to write, so equation, and then dummy variable 2, and that is the equation for the matrix multiplication, and that is the equation for the dummy equation. Basically, dummy variable 2 equals 0 as well. Then I call this answer, that's the model name, and then I include this equation and this equation, because those are the two that I want to solve now. So solve the model using LP, minimizing the dummy variable 2 in this case. Okay, and then display the value. So this is the solution, this is the right-hand side, and this is the new inverse, basically the inverse matrix I calculated here. So if I run it, I should obtain the solution of the problem. So if I run it now, then I have, so it tells me that x equals 1, y equals 2, and z equals 3. The solution. This is the right-hand side, and this is the inverse matrix. Okay. I hope you find that useful. If you're new to this channel, don't forget to subscribe and hit the notification button. Thank you very much. Bye.